you doing? Is this, it's working, it's live. Okay, that's a good sign for the start of an event. Hey, I've been told I have no more than 8 minutes, and then both the smarter and the younger people will take the stage. And so, so I will not trouble you for too long. First, I wanted to thank you all for attending. Obviously, this is our first event ever, like the first event where we actually see people live, and it's pretty darn exciting for us. So it's great to have you here. I wanted to thank the folks who put all this together. Our team here and the team that assembled this has done a great job getting stuff ready for you today, and has taken a lot of care and thought with the agenda itself. I wanted to thank our sponsors, Amazon, the folks at Grafana, an important partner to us, and Seek, a specialty in the IoT field. We are really thankful for your support of this event. But mostly I wanted to thank you guys. We try to do something different with this, is we take very seriously this idea of community at Influx. It's sort of the foundation of how we conduct our business and how we think about our products and how we think about engaging with the world. And for us, this community, the community idea of whether you're a paying customer or you're using the open source, we want to find ways to support you guys, to support the builders out there who are working on our stuff. And we want to create venues, opportunities, information, education for folks to do that. And we also want to create a situation where people challenge us on our vision, our ideas, so that we continue to evolve the project and the dynamics of it. So today is set up not as a commercial for Influx. It's set up as a bunch of industry thought leaders, and Paul will take you through the agenda in more detail, talking about things to do with metrics and events and how to work with it. And what we've tried to target for this event is the people who are viewing themselves as builders in this market and who really want to develop a deep expertise about metrics and events. And if that's on Influx, that's great. If it's on something else, that's fine. We want to have that dialogue. We want to have that discussion. So the way we've set up today is we have Paul leading off, and then we have a bunch of thought leaders in the industry talking about how all of these dynamics are changing and how our view of both open sourced and general compute infrastructure is changing, and the IoT world, and a variety of different topics. And what we've not tried to do is jam a ton of content in a short period of time. What we want to do is create a fair amount of time for you in between sessions, for breaks, for networkings, for discussions, for you guys to talk to us or to talk to your peers about what's going on in the industry and the dynamics at large. And so we've set this up that way. I hope it goes. This is our first ever InfluxDays. Hopefully you guys will look at this in 10 years and say, you'll have a bit of a badge of honor as I was there for the first event. That's if we execute these events successfully and you love it and all that sort of stuff. So at a high level, just at a very, very high level, I feel like we're at sort of a unique period of time. I started my career in aerospace, and we made sensors. I worked on a commercial aerospace platform, and we made sensors that cost $1,000 each, that were a magnetic coil that had 2 states, and they were very expensive to install, that still run on airplanes today. And the systems that basically, the software systems that behind it take 2 years to develop. And it was just a very, very different world than the world we live in now. And the way I think about it is we live very much in the world of instrumentation now. The combination of ever-present and increasingly connected networks that are largely available across large surfaces of the Earth, the incredible manufacturing prowess that is giving us sensors that measure humidity, pressure, temperature, a variety of surfaces, change over time at very, very cheap implementations. On the software side, we're dealing with a tremendous fragmentation of the software infrastructure as we move from dedicated applications to ephemeral microservices and containers, things that are up and down and transient all the time. And so what we find ourselves is a tremendous capability to instrument everything, and in both the physical world and the virtual world. And at Influx, what we're trying to do is create a platform that allows people to run those workloads, those instrumentation workloads on our stuff at scale with high cardinality and with increasing capability. That's our focus, that's our intention. We think it plays into the world. What we hope is that you guys are in a mode where you're coming and you're saying, listen, we know a lot about metrics and events coming here, and we want to share what we know, but we also want to learn what some of these thought leaders and what the Influx folks are thinking about the way this starts to evolve, both in the cloud-native software world and the virtual world and the business process world and in the hardware world, instrumenting the physical landscape. And so that's our intent for the day. If you need any help, I have these special notes. If you need any help, there are people with green jackets that can tell you a variety of things, maybe even where the bathrooms are, and that sort of stuff. So look for the people with green jackets. I'm also supposed to say, we're recording these sessions, and so they'll be on YouTube in some delay of time, maybe a week or so. And if there's any kind of emergency, which I hope there is not, we're requested to leave the property right away, and I assume that means just go out on market and go. And we're hoping you guys can stay after for the sessions, stay after sessions for a happy hour, to hang out and to engage and talk. And so feel free to grab me or anybody with an Influx shirt or any employees or anybody during the day if you have any questions. We are truly honored to have you guys here. With that, I want to introduce my partner, our co-founder and CTO, Paul Dix. So I met Paul roughly a little over 2 years ago. And the thing that I really liked about Paul, which I hate to say in public, I don't like to say that I like anything about him in public, but the thing that I really liked about Paul is he had a really, as an entrepreneur, he had a very unique point of view. And I think for successful companies to be built, and I would say this for successful projects, is you have to come to it with a unique point of view. And so Paul had a very unique point of view about what a great time series database would look like, what should be the components, how to think about it, right, and how to develop it. And for him, that meant first and foremost, and I think it's buzzing, how quick was it time to value, or what Paul calls time to awesome, right? That was his first thing. And the second was, how can you embed these very difficult time series intrinsics into a purpose-built database as opposed to using a general purpose database and then storing metrics and events. And I think this is the fundamental beginning of a new wave. And I think it was Paul's point of view coming into that market that helped define all of that stuff. And I consider myself a product guy historically, but when I met Paul, I realized that, holy mackerel, this guy has really got it. And so, and I hate to say that publicly. If you know my relationship with Paul, you'll know that we harass each other all the time. And I think he's done a great job steering Influx. And I think hopefully what you get today is there's no way we're done. Like, we keep rethinking. We keep thinking about how to make this platform better, how to change it, how to make it more dynamic. We engage deeply with other projects in the community, whether it's Prometheus or Open Metrics, to figure out how we work so that this platform has a life unto its own long after we're gone. So with that, with no further ado, let me, oh, look at his picture up there. Let me introduce Paul. Paul Dix, ladies and gentlemen. So. No, I got it.
I'm not on? Oh, wait, I'm on now. Okay, great. So thank you again for joining us, and thank you, Evan, for the great introduction. So as you might have gathered from the title, today I'm going to be talking about IfQL, or what we're calling the Influx query language. So what is IfQL? It's actually multiple things. It's not just a new query language. It's a new query execution engine. And it's a separate standalone binary that runs as kind of a sidecar next to InfluxDB that exposes new query functionality. So let's take a really quick look at the query language, and I'll get into some of the reasoning about why we're building this, what the goals are, and that kind of stuff. So here it is. It looks kind of like JavaScript. You have a set of functions that are chained off each other and they have named arguments. So in this query, we're getting everything from the CPU measurement and the usage system field that matches the tag service equals app server. And we're getting the last 12 hours of data. We're windowing it into 10-minute buckets, and then we're getting the max. So the equivalent InfluxDB 1.x query looks like this. So at the bottom, we have our SQL style syntax. One thing you'll notice, actually, that's important to point out is that the group by time at the bottom has the group by star. So in IfQL, this is the default behavior. We always separate things out into separate series and actually have the user explicitly state what kind of grouping they want to do later. What we found over time was that people would often get confused by the results that were being returned because we would merge a bunch of time series together by default unless you had this group by star argument. So as I mentioned, there are functions. It has a function chaining syntax, which will look very familiar to people who use jQuery or D3. We took inspiration from those projects. We have named arguments, not positional arguments. And we also have this expression language for specifying predicates. And this was actually one of the places where we kind of diverged from the purely functional style. The joke I make is if we had made it purely functional, it would look like Lisp. And of course, Rich Hickey and Paul Graham couldn't make Lisp popular, so neither will we. So instead, we opted for something that looks a little bit nicer to read and nicer to type. But this will also be adding something which will let you specify this as a JSON object if you want. We have comments, which are nice. We also have variables. So for those of you who are familiar with Capacitor, it has this functionality. You can assign things to variables and then call off of those. So now we have this in the query language itself for interactive dynamic queries. So let me talk a little bit about the new execution engine. And this is a big thing for us. So it looks kind of like this, right? Like I said, there's IfQL query processor, which is a separate thing. It's a separate binary that runs, that communicates with any number of InfluxDB servers. So we have processing here at this tier, and then we have storage here at this tier. And our goal with these IfQL processors is that they're a shared nothing architecture. So you can spin them up really, really quickly within a container. They can process a query, either just one query and go away, or they can be long-lived and running and processing many, many, many queries. So I'll go into more specifics about the language, but I wanted to talk about some of the whys of it. In my mind, this is the biggest API advance we've had since the release of 0.9 about 2.5 years ago. So when we went from the 0.8 version of InfluxDB to the 0.9 version, we introduced tags, which opened up all sorts of new use cases. The unfortunate thing was we basically had to break the API. There was no clean upgrade path for people to go from 0.8 to 0.9. But the difference with this is it's designed to work with InfluxDB. So we released 1.4.1 last night. And this IfQL processor works with that version of Influx. It works with the data you already have. There's no migration necessary. It's just out of the box. So why would we actually go to the trouble of creating yet another query language and yet another execution engine? It just seems like a lot of work, right? Technically, we have two languages right now. We've got InfluxQL and we've got TickScript. So why are we doing another one? And the primary reason is really about features and feature velocity. We want to have new features, new functionality, and we want a language that's flexible. What we found with SQL is that it's frequently inflexible for this time series use case if we want to add new functionality. So looking at some of the issues on GitHub, this one, for example, math across measurements, this has been requested for over 2 years. There's 90 comments on it. This is like the most requested feature. Last fall, we actually took a stab at trying to do this. And we found we had two problems. One was the engine, our current query engine wasn't really designed to be able to handle this use case. And the other was, it was hard to introduce this feature into our SQL dialect without having the language like start to not make sense syntactically. Basically, like anytime we want to add a feature to the language, we have to think about the language as a whole. Whereas the functional style, we can add a new feature to the language by just adding a new function. We don't have to think about how it affects the rest of the language. So distinct to operate on tags. Again, if you look at I'll go show some queries, but in the queries that we have in IfQL, we kind of represent everything regardless of it's a measurement or a field. We represent it as tags. So this will get kind of out of the box really easily. We want to be able to support different groupings of times and natural time boundaries. So if you want to group by a week or a month or a year, we want it to align with the time boundaries. And we actually want people to be able to specify more complex criteria. So say you wanted to, group by week, but you wanted Monday to be the start of your week. If we have functions for specifying the behavior of this windowing stuff, we can add that in without it being like some complex thing that we have to figure out how to shoehorn into our SQL dialect. This date part one is an interesting one. So this is a request we've had open for a while. People say, like, I want a week's worth of data, but I only want the same 8-hour period for each day from that week's worth of data. So to do that right now, you would have to have this very, very complex where clause in the SQL where you specify all these different time ranges. Whereas I can think of a way, we haven't added this yet into IfQL, but it's definitely something we want to get to, where we can say, okay, give me this time range, but here's another argument on this function to say, leave out this other time range within those blocks of days. So wire up series order, this is the top N use case. So say you have a bunch of hosts in a data center, and you want to say, give me the time series for the 20 hosts that are under the most load, so you can track those down. That's what this one's about. And again, this is something that we've just designed from the very beginning in IfQL to be able to handle. Support for the halving clause. And basically, there are a ton of other functions and query operators that people want. They're probably about, this issue is kind of like a catch-all for things we want to get to or things people have requested. And there are probably like 55 different requests, like feature requests in here that we would love to get to, many of which have been open for years, that we haven't been able to get to because we've been pigeonholed by the language that we have. So ultimately what we want to do is we want to increase our feature velocity, and we want to make it easier to deliver these features. So that's what I'd say is the primary goal of IfQL as a project. But a secondary goal is we want to unify InfluxDB and Capacitor. So right now, we have basically two separate languages. We have the SQL dialect for querying the database, and that's for interactive queries. And then Capacitor has something called TickScript that looks like this. Now, the existence of these two separate languages is kind of an artifact of how the company was built over time. We built the database, we saw what people were doing with it, and we saw that one of the common needs they had was they wanted to monitor the data, process it, do ETL tasks. So after I raised the Series A round, we had resources, and we started to build a team to build out these other pieces. And we brought Nathaniel on, who's the lead of Capacitor. And he and I brainstormed over the course of a few weeks to come up with the first version of TickScript. And at the time, my thought was, obviously this looks kind of functional as well. And my thought was the functional paradigm is actually superior for working with time series data. And I had this idea in the fall of 2014 when I was talking about the change we were going to make from 0.8 to 0.9, where I was adding tags. I also briefly considered changing the query language. And the problem that I found at that time was the users and the audience were basically split in half. There was no consensus. One half said, no, the SQL dialect is what makes the project great. It's what makes it easy to use. Don't leave it. And then the other half said, no, the functional paradigm is what makes sense. You should absolutely do that. Now, I am now firmly in the functional paradigm camp. I think when you're working with time series data, it makes more sense to think about functions that you're passing data frames to, kind of like you see in the Pandas project in Python or the the Tidyverse projects in R. And I think that just makes more sense. So for the new language, what we wanted is a language to unify the two platforms, to unify capacitor and influx. Learn one language, use both things. Now, we obviously have to still support TickScript, and we still support InfluxQL, but once IfQL is ready, there will be one language for users to use if they want to, or they can continue to use the previous ones. But one of the very nice properties about this is that it makes it far easier to develop and debug capacitor tasks. This is a very common thing we see in the capacitor user base is it's really tricky for people to develop a task and know what's going on. But in this case, the engine works for interactive queries or for background batch, which is like batch jobs in capacitor that run periodically to do some checks, or for streaming queries. So a nice property of this functional style is that you can kind of do iterative building of your queries. So you can execute each piece and see some results coming back. Right? So here we just have the select. So this basically says, just get me all the metadata from this database. The where filters the metadata that you want to look at, right? So we only want to find series that match that expression. The range gets us actual time series data where we say, oh, now we want to look at the last 12 hours worth of data for all those series. Window basically just says we want 10-minute partitions, here in this case, and then last, which is just a selector that says, give us the last, right? We can build on top of each one of these things over time and execute each piece to see what data we're getting back. And this is a property that you don't really have with a SQL-style language. I think a SQL-style language, you actually have to think a lot more about how you're writing the query before you even get started. So then we call like derivative, right? So we're getting the last value in these 10-minute buckets, and we're calling the derivative on that. So the other nice thing about, I think, this functional paradigm is the way I think about it is like each function is basically a set of transformations on the data that you're passing to and across the functions. Now, the real implementation details aren't that we're actually passing a full data frame and all this other stuff. Like the query planner will optimize things based on what it sees. But as a user thinking about it this way, I think it's much cleaner. And one of the other goals we had was we wanted a language that was much better for query building user interfaces. So if you look at Grafana, I think the graphite interface in Grafana is kind of like the gold standard for a query building interface. It's really clean, right? I think it's due to two things. One, graphite is a functional style language, so that helps because you can basically just drill down. And the other is the hierarchical thing. Now, we're not going to do hierarchies, but you can kind of simulate that via tag search, like faceted search. So ultimately, we want something that's nicer for user interface builders to work with. And finally, we wanted one engine regardless of the context in which the data is being processed, right? So right now, we basically have two query engines. We have one in capacitor that does a bunch of processing, and we have one in influx, which means we're doubling up on the work. And ideally, what we'd want to do is unify all that stuff so that if we find a bug in one and it gets fixed in both. So some of the other kind of design goals for the project, which are, some of these might be a little squishy, but we want it to be familiar. Right? If you look at TickScript, it looks basically different than any other thing you've seen. So ideally, it would be something familiar. It'd be something where you can look at it, and you're like, yeah, I think I kind of know what's going on here. I think I've seen something like this before. This could be JavaScript, right? We want it to be easy to read and understand. So this is one of the things that I think is one of the greatest strengths of Go as a language is that it's optimized for readability. Because the idea is you read far more code than you ever write. So the best thing to do is to optimize for readability, right? So that people coming in can read and understand the code that you've written, which means it's not necessarily optimized to be the most terse and succinct thing. Like an equivalent PromQL query will represent some of these things in a smaller amount, but we think it's readable, right? So this is one of the reasons that we picked named arguments. With a named argument, you don't need to look up the function definition for window, for example, to know what that 10M is. The 10M matches with every, which means every 10 minutes, right? The expression language for predicates. Again, like we chose this because we thought it would be easier to read and understand than some weirdo Lispy like language where you're passing a bunch of functions around. But depending on your love for Lisp, you may disagree. So we wanted to be flexible and extensible. As I mentioned, with the SQL-style dialect, we frequently run into problems where we want to add a feature to the language, but we can't figure out how to do it without breaking a bunch of the other stuff. So again, coming back to named arguments, the advantage of named arguments over positional arguments is if we introduce a new argument to a function in a later release, we won't break people's code, right? Because you have to specify the names. As long as we don't change as long as the new argument is not a required argument, in which case it would break it. So one of the other design goals for the engine, the implementation, is we wanted to make it easy to add functions. We wanted people to be able to add functions to the language without having to understand the entire context of the database and how it works and all this other stuff. So Telegraph is our data collector, and when we went and created the initial design for it and how the project was laid out, that was an explicit design goal. We wanted people to be able to add input plugins to Telegraph quickly and easily without having to understand the entire Telegraph code base. And as a result, we have over 100 input plugins, I think maybe 10 of which were written by us, and the rest were written by community members. It basically makes it far easier for a community member to come in and submit a plugin. And actually, Telegraph as a project probably has more community contribution velocity than Influx does, which is shocking when you consider that we only have one developer kind of taking care of and shepherding that project. Thank you, Daniel. So what we did in IfQL was we organized it like this. So there's a folder called functions, and as you can see, there are a bunch of different files there. So we have one Go file for the actual implementation and one file for the test. And again, this is another place where I think the functional paradigm shows its strength, because it makes it trivial to create a unit test because it's just a function. You have inputs and you have outputs, and it makes it really clean and easy to do unit tests. So our goal here was we wanted a single place that you could go to where you could define a file and insert the stuff. So getting into the actual code is beyond the scope of this talk, but I did do some captures of it just to show. So this is like the count function, and basically like we have a spec, we have the registration stuff, we have the actual implementation, and we have handling for different types. And that's it. 3 screens of code. And what that does is that actually adds the count function to the language so it can be parsed by the parser, makes it so that it can parse those arguments and the different types they have, makes it so that it can actually execute the function. And in this case, count actually defines push-down logic, which I will get into in a second. That's not necessary for all functions. So one of the other goals for the project was we wanted to decouple storage from compute. And there were a few reasons for wanting to do this. So the first is your storage tier, like introducing a bug in your storage tier is really, really bad. So bad. So you don't want your storage tier to have high velocity in terms of code churn, right? Ideally, you're introducing small changes that are optimizations and fixes and stuff like that. But that is kind of directly at odds with the idea that we want to deliver features faster. So what we wanted to do was to have a separate processing tier that we can iterate and deploy more frequently than the storage tier without having the risk of a bug being introduced be as high. And the other nice thing is you can scale them independently. We can just add more and more of these query processing tiers. So this is a really nice thing. One of the long-running requests we have is for a feature called intelligent rollups. This is kind of like in Graphite, where you can just say, downsample everything in the database, give me like 10-minute summaries and 1-hour summaries, right, and these different things. Now, we really want to add that feature, and it wouldn't be that hard to add the feature into the data, just directly into the database, but it almost certainly would completely destroy performance. So that's the problem, is we couldn't add the feature because it's too risky to add it in the database and have the whole thing just fall over because it starts doing a bunch of extra work. If we can pull the processing out, we can have a separate independently scalable tier that can do that downsampling for us. So this is actually in service of delivering one of the most long-standing feature requests for the database. And the other nice thing is, the way we think about it is, like, right now we have InfluxDB as that storage tier, but we could potentially have it pulling from, say, cold storage or long-term storage, like an object store or HDFS or something like that, right? And that's what Amazon Athena does. This is their, distributed query engine. It's Presto, but it's based on top of S3. You pay for the data you store in S3, and then you pay for the actual queries that run. We'd love to be able to do the same thing with Influx, because we see frequently that people have, windows of time that they want to keep hot, and but they want to have it colder data accessible. The nice thing would be if the database just handles it for you, if it handles pulling it from cold storage for you and returns a result. It might be a little bit slower than if you're hitting the InfluxDB storage tier, but it would just work out of the box. Finally, we wanted to achieve workload isolation. So this one's really important. We see, for our larger customers, we see more and more of them asking for what I call multi-tenant features, where they can do rate limiting, they can do workload isolation. They can say, like, oh, queries can be run, and one person who's, I'd say bad actor, but usually it's not a bad actor, it's somebody who just deployed some mistake code to production, we could bring down the whole system. So if we can get workload isolation, one bad actor, you kill its Docker container and then you're good. This is also really nice for data science tasks. What I've seen with large-scale production deployments of, say, Cassandra is they'll essentially run two halves of the cluster. They'll have a cluster and they'll bifurcate it. So one half of it is essentially, they basically double the size of the cluster. So one half runs production infrastructure for your app, and then the other half is the data science tier. And the reason they do that is because the storage and compute are intrinsically tied together. The problem is it's way more expensive to keep your data hot and indexed for querying on a bunch of VMs than it is to keep it in, say, a cold store in S3 and be able to spin up query processing on the fly. And data scientists generally aren't looking for queries that run in real time, right, in milliseconds. It's okay if it takes seconds for it to run, and we would love to enable those kinds of workloads, those data science workloads, without people essentially having to run two clusters. And the other nice thing about having this decoupled storage and compute infrastructure is, one thing I've seen, so I talked to a company that was running a very large OpenTSDB installation, which is a time series database based on HBase. And they had a 200-node HBase cluster. And they didn't have that many HBase servers because they needed the compute infrastructure to handle the writes or the queries. They had it because they had that much data at rest. And they were literally just adding servers to give themselves more storage capacity, which is ridiculous. I mean, it's wasteful. It sucks. So we wanted to make it so that you could have basically this idea of tiered storage, right? You have cold storage, which is on cheap spinning disk. And then you have kind of the hot storage, which is in memory or local disk. And then, of course, actually just like caching tiers. So I'm going to talk a little bit about how this works, the decoupling storage from compute. I say we're decoupling storage from compute, but that's not totally true. It's kind of true. So basically, we have a query here. We're going to send it to the IfQLV process, right? And then what it will do is it will look at the query and figure out what in the query can actually be pushed down to the storage tier. So in this case, our storage tier is InfluxDB. And we push down the predicates, so that's the where expression. And we push down the range. And we can even push down the windowing and the count. Think of this as basically the map phase of a map-reduce job. But it just happens on the fly. And then what those servers will do is they will respond with the summary information, right? So we'd expect 72 data points from every series that match that where expression. And then the IfQLV process will combine the results and return the actual time series data to the user. So that's like the reduce phase of a map-reduce job. And because the language has variables and you can do things, you can essentially create what would be a multi-stage like map-reduce pipeline, but in IfQL. So you can do a lot of stuff with it. Another design goal was we wanted to decouple the language from the query engine, right? So the language is IfQL, that functional-looking thing, but the query engine doesn't really need that to process. So what we do is we have a parser that parses it into a directed acyclic graph, which can be represented in JSON, right? So this isn't the whole thing. This is actually just part of that query from the previous screen. But you can see that we have the select and we have the where clause. All of it can be represented as JSON, which is nice because, say, if you're working in a front-end JavaScript user interface and you want to build a thing, you could actually just build a query using the raw JSON spec for the DAG. So one of the goals there is, like I said, we still have to support InfluxQL and TickScript. So what we want is we want to be able to parse those languages into that DAG that can be executed by the engine. So right now, today, we have IfQL, but we will be adding an InfluxQL parser, TickScript parser, and hopefully early next year, a PromQL parser. So you can use any one of these languages on top of the database. And potentially some other language that other people can think up. So some of the improvements I want to go over really quickly. This is by no means exhaustive, but just to give you an idea of some of the things that I think we got out of the box, even though this is an alpha. So one thing that's important to note, so for this query right here, we have the where clause, we have the range, and we have max. So basically what this would return is it would return one value per series that matches that where clause. And the value would be the max in that 12-hour range. So the windowing function is kind of special because it doesn't actually really transform the data so much as tell the execution engine what to do with it. So what that window would do is it'd say, okay, break it up into 10-minute chunks. So what we get is one value per series for every 10 minutes. But the other thing is you can call the aggregate again, even though this may or may not make sense. So in this case, we're getting the minimum value in every 10-minute interval, and then from those, we're getting the max of those values. So the aggregates or selectors or functions, they essentially work on the whole series or on the windows if you just previously called window. So another thing is we actually have more flexible windowing. This is very similar to what TickScript does, which is in InfluxDB, basically the windows are all on specific bucket boundaries, right? Every 10 minutes, every minute, whatever. Here we actually can specify how often to tick and what the period should be. So in this case, what we're going to get is every 1 minute, we're going to get the previous 10 minutes worth of data, future 10 minutes. So it will tick every minute, basically. Just like in InfluxQL, you can use matchers against everything. We support all the same ones: regex matching, equal to, not regex. The where expression is also where you can filter based on values. So this is one thing we have that's kind of an oddity to the language. It makes it a little bit different. Don't quite know how I feel about it because it's like a magic super variable, kind of like Perl. So yeah, the $sign is basically match against the value. So it's the filter the values that are greater than 90. And in this case, for this particular query, that would get pushed down as a predicate pushed down to the actual storage engine. So it wouldn't pipe it all back to the IfQL processor. You can also specify times or offsets. And the previous examples, I was just showing an offset, like -2 hours or whatever. In this case, I can specify a specific time. And of course, there's the now keyword, which you can specify like that. Math across measurements, that's here. You can do that now. So basically, we get a bunch of data for one series, we assign it to A, we get a bunch of data for another series, assign it to B, and then we explicitly call join. Now, the join function will join the time series data based on the timestamp, but also based on the keys that you specify. So in this case, if the host name matches, then join on the timestamps and perform this transformation on it. So again, we have the magical $sign, and then we add it to the matching value from the A variable. So basically, that will do essentially like a bunch of matrix math for you like right away. Having queries. So this shows actually an interesting thing, which is we don't necessarily always push down the predicates. So the first where clause, that gets pushed down to the storage engine, so we filter out the data, and then we range a window and we sum it for the windows, right? And then the second where clause filters based on that result. Essentially, what this ends up being is this ends up being a halving query, right? You're doing the aggregation, having value greater than 100. And the where clause basically can be executed like within IfQLD, like on the stream or on the batch, or it can be pushed down to the storage tier. And having that means that we could, right, for example, pull files from cold storage, feed them into the engine, and have it just work. So this one is actually pretty interesting, I think. There's in InfluxQL, right, there's a function where you can get like the max or the min. They're basically selectors that select an individual data point. Now the problem is you could lose the context for those things if you've merged a bunch of the series together. So in this case, what I'm doing is I'm getting the CPU measurement, the usage system for the app server services. I'm looking at the last 2 hours. And what I want to do is I want to group by region, but I want to keep the host information as separate context data, and then cut it into windows and then get the max. And what I would get as a result is I would get my time series data, and I get the series information, where the series information is essentially just one series per region that I have. But then additionally, with the actual data points, I would get the host that matches up with the value that was selected. So you can have that context be propagated throughout a query. This is another one I'm excited about because of the decoupling the query from the compute from storage. We can do federated queries, and this works today. You can specify the host that you want to hit. I don't know if we're actually going to keep this there in the language, or at the very least, we're probably going to limit the functionality to basically say whether or not you want to turn that on or off. Because the IfQLD process, you can also tell it when you start up which host you want to query. But essentially, you could have any number of InfluxDB hosts, and it can combine results from those hosts, so you can build a federated query system. So I'll talk a little bit about the IfQLD server. Like I said, it's separate binary. It's written in Go. It's very simple. It has an endpoint called query, where you pass it a query. You do a post to this, and the query is just influx IfQL, and what it returns is JSON lines. So the original InfluxDB response format was basically this massive JSON object, and the problem with that was we had to marshal an entire query result before we could actually return it, which sucks because then it would be trivial to blow up your database by doing a query that tried to select all the data for all time. So in this case, the entire engine is designed to stream data as it comes through, right? So if you do a query like that, you would just be getting a lot of data, but then ideally you could kill it if you wanted to. So what that looks like is one JSON object per line. The top line is basically a header that specifies the series information, and the line after it is the actual time series data that's associated with the header that we saw. Now, that line right after it that has the data, it may or may not have all of the data for that series, right? We break it up into chunks. I think by default, the chunks are 1,000 points per, right? So you could have multiple objects after that one header, and then a new header will come in. And basically, we return a series ID so you know when that changes. So as you're reading the data off the wire, you could actually use that to figure out when you've swapped to a different series. Those IDs are actually ephemeral. They're assigned by the engine as it returns the data, so they're not like some intrinsic underlying thing that's stored. So another thing we have is you could pass the AnalyseTrue parameter when you post the query in. And instead of executing it, what it will do is it will return that query spec. It will return the DAG so you can see it. And the vice versa, the other way, you could post the DAG as a JSON spec with the content type application JSON, and it will execute that query and you'll get it back. So again, for JavaScript front-end application builders, they may not want to actually create an ORM that creates this IfQL string and blah, 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 right? What they want is just construct a JSON object and post it to the server and give me the thing. And we will also have, I don't think we have it right now, we'll also have it so that you can post a DAG or the query spec and get back the equivalent IfQL query. So you could display it in the browser, right? So there's a whole lot of stuff coming soon. This is under very, very active development. The guys were up until 12:30 last night in the office working on some stuff. What I'm going to do now is I'm actually going to open source this thing. So hopefully we can get people looking at it and testing it. Here. Is that up there? All right, there it is. Okay. Settings. Oh, wait. Let's see. Oh, come on. Be faster. Okay. All right. Make public. Oh, what do I need to do? Type in the name of the repository. All right, IfQL. Oh no! Oh, this was going to go so much smoother. See, this is why I never do live demos. I consider this to be a live demo. It's like the cardinal rule. Okay, hold on. There we go. Oh, I have to do this again? Oh, wait, no, it is. Woo! It's public. All right, so I should mention the license we chose, and I'll talk about that a little bit. So this is AGPL licensed. And the way we're going to treat this is very similar to the way Mongo treats their license, right? We'll have client libraries that are Apache 2 or MIT. Our goal here is we want new projects and startups to be able to use the code, use it in production, get all the functionality they want. But we also want to have the business of running it as a managed service for customers, right? So our value proposition there will be, you can run it yourself, by all means, that's fine. But we don't want the hosting companies to come in, or the cloud vendors to come in, and host it without having some sort of agreement with us. And the Mongo selecting the AGPL license actually made this very effective. And the other thing we'll do is many of the underlying libraries will actually be MIT licensed. So the overall server stuff will be basically AGPL'd, and some other stuff will be MIT'd. But again, the goal is we want people who get value out of it to contribute back to the community. But we also want people who want to run it themselves to be able to do so, and that'll be fine. So how to enable/install it? Basically, upgrade to InfluxDB 1.4. Add this little chunk to your config in your InfluxDB config. Install IfQLV, which we have a Docker image, we have Debian packages, Red Hat packages, and all of this is in the IfQL repo. So it's github.com/InfluxData/IfQL. So really quickly about the project state. I would say this is an alpha release in the truest sense. There's a bunch of stuff that we haven't finished wiring up yet. There's still a lot of functions that we want to add. The API will likely change. We're not locking down the API yet. What we want is we want feedback from the community. We want people to play around with it. And we want to see, are there any spots that we missed, right? Our goal here is to enable the most functionality that we can enable. We want to bring more and more workloads into the InfluxData platform, particularly like data science workloads as well, and we want to make sure that we've captured everything and that this API and this language will be flexible enough for us to go the next 5 years in the future. So our goal is to do an API lockdown early next year. So I've created a couple of short links. There's an issue that we have open on the repo to track implementation progress for InfluxQL functions that we need to wire up, and for tick script functions that we need to wire up. Our goal is that once we get to API lockdown, the functionality of IfQL will be a superset of the database and capacitor. And there's also kind of a rough-ish spec that we put up on the InfluxDB repo, which you can find there. But you can log issues against IfQL if you want to play around with it. We also have on there just like a Docker compose to get a test environment set up in a few seconds. So I wanted to use the last couple of minutes of my talk to talk about releases and some coming soon stuff. So obviously I said InfluxDB 1.4 is out. There are a bunch of features to it. We put up a blog post this morning. Some of the headline stuff show cardinality, so you can see the cardinality of things. You can filter this by measurements and tag keys and stuff like that. There's the Prometheus remote API for doing remote reads and writes with Prometheus, so we support that natively now. There's a Capacitor 1.4 release candidate that we put out. Again, it has a lot of different features. We don't have a blog post on this one yet. Some of the headline stuff are some additional logging information for tick scripts. So there's actually like an API around that, and I'll show that we actually paired up a chronograph feature with that. And then the other big one is loading tasks from a directory. So we heard from Kubernetes users that what they wanted to do was they wanted to create a Docker image that had all their tasks defined, and then it would just be like this ephemeral stuff that they could spin up on the fly, and it would just like work from those tasks. And also we added support for auto-scaling Docker Swarm. So a while ago we added support for auto-scaling Kubernetes based off of any metric that you're feeding into Capacitor. So now we have that same functionality for Docker Swarm. So lastly, chronograph is basically our user interface for the stack. There are dashboarding features and stuff like that. So one feature we added in is basically this time comparison feature. So you can say, if you're looking at an hour's worth of data, you can say, show me the same hour from yesterday, or the same hour from last week, or the previous hour, so you can quickly get like a comparison of one window of time versus another. And then the other big thing is the tick script editor in chronograph. So basically here on the left-hand side, we have a tick script that we're playing around with, and on the right-hand side is actual log data coming from Capacitor as it's processing data for that script. So you can get some visibility into what's going on. So lastly, I wanted to mention that we have a hack and workshop day in our office tomorrow. We're definitely going to be spending some time talking about IfQL. David Simmons is doing a session on IoT stuff, on sensor data. Michael is doing a session on Capacitor. What else? I forgot the other ones. and we'll be doing an IfQL one as well. So it can be either sit in sessions, or it can be talk to us, talk to your peers, and hack on something that you think is interesting. So that's all I have. Thank you. Okay. I don't know if I have time for questions. Do I? All right. Yes.
Thank you so much. Hello. Thank you so much for your talk. It was nice. I appreciate that. Yeah. A quick question about the versioning and release cycle. So which version should be considered stable? Which version we can safely roll out to production and not be afraid of data drops and stuff like that? Just what's your release cycle ideas?
Yeah. So right now, it's basically, I would say it's prototype software, right? So if you have a mirror of production that you can execute against, do that. I probably wouldn't run it against production right now. So we'll probably be cutting releases weekly for the next month or so. My goal would be to get a production-ready release early next year.
But I mean, how do we know, let's say 1.3, which one is production ready?
Of InfluxDB or
is
of
it semantic versioning or?
Yeah, so we follow semantic versioning. So IfQL actually, as a thing, has a separate version number from InfluxDB. So InfluxDB is on the 1.4.1 release. That's the open source. That's tested and we've run it. So that's production ready today. IfQL has its own. So the release we cut last night was 0.0.1, which represents as prototype as it gets, right?
Thank you so much.
Yeah. Yeah, in the back.
Hey, thanks for the talk. It was really interesting. I have a question about IfQL. So can it query multiple Influx backends?
Yes.
Okay, so that means we can shard the data in multiple Influx backends, and for the query, we don't have to process what goes where, right?
That's right. You can do exactly that.
Okay, great.
Yep.
I had one more question. So when will this be supported in Grafana? Do we have a sense of the timeline?
So I've been talking to the Grafana people, and they're excited to get working on it. So hopefully very, very soon. Maybe Dan has a better idea. He'll be speaking here. Soon? Okay. Yeah, our goal would be, as quickly as possible. The next Grafana release, that would be great. The one thing I'm sensitive to is I don't want to waste too much of their time because, as I mentioned, the API could change. So that's the tricky part is we want a little bit of wiggle room to be able to iterate on the API based on the feedback that we get. So kind of depends. But yeah, like I said, one of the design goals of the project was to make it so that you could build a better user interface around the query language. So yeah.
Thanks.
Hold on. Did I get? Okay, yes.
Thanks for the talk. Does the separation of the processing and storage have any future impact, you think, on high availability without having, for the open source part, without having to run that relay, but having the, IfQLD server kind of handle copying or doing anything like that?
I mean, people certainly could use the IfQL stuff to build high availability stuff around the open source. Over time, our goal is to open source as much of the platform as we can. right? So at the time we made the decision to have clustering be closed source, it was the right thing for the company because we had to build a business. But as we get farther and farther along, we have the potential to change the value proposition that we're offering to the customers and make it so that we can actually open source more and more of those bits, which is one of the reasons why IfQL is fully open source at this point.
Hey, so one of the reasons that people are sometimes reluctant to create new languages is that there's a lot of tooling around languages, like syntax highlighting and editor integrations and like autocomplete that's just kind of hard to do, but not really part of the core language. Do you guys have a story around that?
Well, so we will be creating, at least within Chronograph, like an editor for it. We would like to work with people to create like definitions for doing syntax highlighting and ideally autocomplete stuff. The JetBrains people had actually contacted us about doing stuff for TickScript. I hope that IfQL will actually represent something that's easier to do. The truth is, like, we don't really get the advantage of having the tooling stuff because our language isn't SQL. As anybody who actually really is an expert in SQL will tell you, our language can be quite frustrating because there are things that you will try to do that you would expect to work because they do work in SQL that just won't work. So we kind of, because of that fact, we don't really get the benefits of all the tooling around it. We essentially have a new language, but we don't, it won't work with those things. So I mean, I guess we could have just used JavaScript as the language, certainly. But yeah, it's one of those things that I think if we get enough velocity over time, that the tooling will be built. And we'll be trying to build some of that ourselves. So, okay, looks like I'm out of time. So, all right, thanks everyone. Oh, what? Oh, we're gonna do a break now. Sorry, I have to switch over into MC mode now. We're gonna do a break so everybody can talk to each other or whatever. So 15 minutes, is that right? All right.